All right, well, this is a new feature, and these are quick review videos. And so just a couple moments, I want to do a quick review of each of our lessons. So this is sets of numbers. All right, so remember, you start in the inside. And what are we doing? We're doing all the real numbers. All the real numbers. All right, so all the way inside, natural numbers, counting numbers. 1, 2, 3, 4, and up, right? Okay. So if you take the natural numbers 1, 2, 3, 4, 5, 6, 7, etc. and add 0, we're going to call them the whole numbers. Now I want to stop and pause and real quickly review a concept. Notice how all of n is inside of w. All of n is inside of w. Whenever all of one set is contained in another set, what's the symbol? It's right here, and that's the symbol for what? Subset. Whenever all of one set is in another set, it's subset. Okay, so the natural numbers are a subset of the whole numbers. Then you go to that outer red circle, and Z is the integers. All right, so this is the negative numbers, also the positive numbers. So take the whole numbers, 0, 1, 2, 3, 4, 5, 6, and add -1, -2, -3, etc., and you'll get the integers. Okay, so the natural numbers are a subset of the integers. The whole numbers are a subset of the integers. Okay, so what's Q? Q is the rational numbers. Anything that can be a fraction, 1/4. Two-thirds. That's easy to see. What if it's in decimal form? All right, well, 0.5, we know that that's a fraction, right? That's 1/2. How about something like 0.125? How do you know if that's a fraction? All right, well, if it's a terminating decimal, it's a rational. It's a fraction. It can be a fraction. And if it's a repeater, right, for example, 0.3 is a repeater. So it doesn't end, but it repeats. That's a fraction because we know 0.3 is 1/3, right? Okay, the last thing to the right are the irrational numbers. And an irrational number is something that can't be a fraction. For example, square root of 5. So there's no integer numerator divided by an integer denominator to get the rational numbers. How do you know these in decimal form? Well, these will be non-terminating, 3.145, etc. That's the number for pi. It doesn't end, but it doesn't repeat. If a number doesn't end and doesn't repeat, then it's irrational. You can't make a fraction out of it. Okay, so are the rationals and irrational subsets? No, none of the rationals are in the irrationals. Okay, so let's keep up with this quick review. Hey, we got two sets. J is 0, 1, 2, 3, 4, and K is -3, 0, 3, 6, 9, and 12. Remember what that symbol means? The green symbol in between the J and the K? And hopefully you're thinking intersection. We want to intersect them. Okay, so Venn diagram, right? So there's set J, and now I'm going to draw set K. I'm going to grab my black here, and I'm looking at what K contains, and I see K also has 0 and 3 in it. And by the way, that's why I wrote the 0, 3 over there. So K also has a -3 in it, a 6, a 9, and a 12. Now, how do I show the intersection? Well, I shade the parts where they intersect, right? And the numbers are 0, 3. Hey, one other operation. And that's that operation. The U in between is an intersection, but it's what? I hope you're thinking union. And what's union? You put everything together. So if I were to show the union with a Venn diagram, it would look just like our one above, only I would shade everything, right? The union, putting them together. All right, sets of numbers, intersection, union, and subset.